That's the sound that computers make. Why is quantum computing so potentially powerful? Alliteration. So in the news, you may have seen that Google's Sycamore chip, as they call it, a quantum computer, has recently achieved quantum supremacy. You may have heard about this. And to do this, they have shown that their quantum chip, using quantum mechanics, can achieve a very complicated mathematical computation very quickly, much faster than the fastest and most powerful supercomputers on the planet. But first, what is quantum computing? Well, you may be familiar with classical computing, which uses memory and moves things around with computation like a Turing machine would, and you're familiar with bits. So the easiest form of bit to think about is a pair of bits, a 0 and a 1, to form binary or some kind of information, an on or an off state that you can use to code in information into memory. So there are 4 possible combinations of that pair of bit. 0, 0, 1, 1, 0, 1, 1, 0. That takes some information, some coding that needs some space to fit within classical computing. Now, where quantum computing comes in and makes such waves is that a quantum bit, a qubit as they call them, takes advantage of a principle of quantum mechanics called superposition, where a value doesn't have to be a 0 or a 1, it can be both at the same time. They're superimposed on top of each other, and it sounds weird, but quantum mechanics is very weird. So the idea is with a quantum bit, a qubit, you can have superimposed bits for all of these classical values. And so the example would be that instead of having 4 separate placeholders for this one pair of bits with 4 possible combinations, your quantum bit, your qubit, could have all of these represented by the same pair of bits. And so the amount of storage, the amount of information you can compute, rises exponentially with the number of qubits that you have. For example, if you had 3 qubits, you could have 8 possible combinations. If you had 4 qubits, that's to the power of. If you had 4 qubits, you could make 16 possible combinations. Now, the quantum computer, the Sycamore chip that Google is using, has 253 qubits with 253 different values associated with each of those qubits. And that means a possible number of combinations of about 10 quadrillion. So with all of these qubits, and all these possible values and possible combinations and superposition and entanglement at work, which we don't really have time to get into, but quantum mechanics at work, what can a quantum computer like this do? Well, to demonstrate quantum supremacy, they took a problem, a mathematical problem, which is effectively like asking a computer to say, I want you to list out a long string of perfectly random numbers, and then I want you to check that that string is random 1,000,000 times. And just to give you an idea, that doesn't sound that complicated, but for the fastest supercomputer, classical supercomputer on the planet, that computation would take about 10,000 years. What could a quantum computer do? Well, Google, in a paper published in Nature, if you want to read it, said that they could do it they did it, in fact, in 200 seconds. So given that this is 1.5 trillion times faster than the fastest classical computer on the planet, you can see the potential applications of something like a quantum computer to compute very complicated things very, very quickly and achieve a new style, a new way of thinking in computer and machine learning and all that cool stuff. I will say, though, that this problem they asked the Sycamore chip to compute is pretty esoteric. It doesn't have a whole lot of applications outside of the world of quantum mechanics and quantum computers, but they demonstrated that they're 1.5 trillion times faster than the thing that you're watching me on right now. Well, much faster than that because you're not watching me on a supercomputer. And if you are, stop wasting government tax dollars. So that is the promise of quantum computing. By using quantum mechanics and the principles of superposition and entanglement, you can process a lot more information a lot quicker, bringing calculation times that would take more than our lifetimes down to just a few minutes. That's amazing. Hello, and welcome to another edition of Because Science Live, the live show on the Because Science channel where I take all of your comments, questions, corrections, and weird comments about my hair and face and things I do outside of the void, and I try to answer them off the top of my head. Look, I'm not a working scientist. I'm not a professional nerd. Well, I am. I'm not a professional scientist. But, hey, I'm a professional nerd, and I know a little bit about a lot of sciencey and pop culture stuff. So if you have any questions for me, you can put them in the chat on YouTube, and Voice of the Void Nate will get to the best ones. Please do not spam the chat, or else we will never get to it. And before all of this starts, if you like YouTube, you are probably aware, and you like science YouTube especially, you're probably aware of what will probably amount to be the biggest YouTube collaboration in the history of YouTube. I think a combined subscriber base of 750 million. And that collaboration is called Team Trees. Hashtag Team Trees. What we're trying to do is, working with the Arbor Foundation, we are trying to raise $20 million to plant 20 million trees by 2020. And this started off as just a Twitter suggestion to Mr. Beast, but they made it real. I think it's even on Discovery Channel that they're doing this. So all of your favorite YouTubers are getting in on Team Trees. We want to plant 20 million trees. You can go to teamtrees.org and you can donate. For every $1 donated, that's one tree planted. Even if we do this, even if we plant 20 million trees, it's not going to solve climate change. It's not going to solve all of our environmental problems, but it will show that we have some drive, some passion, some impetus to do something together that's positive, that can affect the environment in a great way. So Team Trees, hashtag Team Trees, get in on the action, donate. It's for a very worthy cause. Nate, what up, man?
What's up, professional nerd?
Hey, I don't know what to put on my business cards these days. Hair guy?
Hair enthusiast.
That's true. What do we got?
First question is from Zach Chast. Can you explain the science behind songs getting stuck in your head?
Earworms, the science behind earworms, and I don't actually think that I can. I know that it's a neurological and psychological quirk where you hang on to certain bits of songs or not, but I don't know the actual neuromechanics of it. I know advice to get that part of the earworm out of your head is to sing the song all the way through, and that kind of resets your working memory of that little thing you keep singing over and over. And I can't even give you an example because it will cost me money. What's next?
From Rob Cunningham.
Hello.
If you were to substitute in a high school physics or engineering class
I would
for
love
one
to do
day
that. I would love to do that.
and could teach any topic you wanted, what lesson would you give?
I would love to go into a high school classroom, or maybe I'd love to go into an 8th grade classroom and teach like Intro to Physics or Physics 101, a class that they would take in high school, for example, or in college, and put my own spin on it. I would love, and I encourage science educators to do this all the time, I would love to try to put an actual curricula into my own words, into my own thinking, my own examples, my own math. I would love to do that for students because my intuition is, look, I'm probably not the best teacher in the world. I mean, there's certainly great teachers out there. But I think if I really applied the kinds of stuff that we do on Because Science to something like a lesson plan, I might be able to make it very fun in a way that a lot of students don't get. I was very fortunate in my education to have a lot of wonderful teachers. So if I could be a good teacher to someone, I would love the opportunity to do that face-to-face, even though we try to do that here each week. And that's not actually something I want to do, doing like videos that are more a basic lesson plan as if I was your substitute teacher. We might return to that, but I would love to do it. So it's probably Physics 101, something like that.
Some people in chat are also noting that Team Trees has already passed the 1 million mark.
Already a million trees will be planted. That's incredible. Just replicate that 20 times. No problem. We got this.
From Matterbeam.
Woo! OG MB.
He's kind of talking about your running test and anime running.
Sure. So the episode we just did, we found that anime running, or Naruto, style running was 3% slower for both noobs like myself and gold medalist sprinters. Can't believe she did that with me. That was great.
He's asking, what fascinating discoveries are we missing out on because no one is testing them rigorously?
Yeah. I wonder, that's a great question because if you just mechanically think of what goes into scientific research, it's grants and money and time and resources and people, and there are just some questions that will never get all of those factors to coincide with doing a study on them. And sometimes it takes a person like me or someone who has time on their hands and a budget to test very odd things. And it would be impossible for me to speculate what we are missing out on because we haven't studied it yet. But the kinds of stuff that I would love to do, just as a way to show like how experiments work, double-blind studies, the mechanics of science, and how we learn things about the universe, I would love to do silly studies if I had, my means, where, you could... The one that I always think about is I would take that song by the 80s guy with the beard. Never Gonna Dance Again. Guilty Feet Have Got No Rhythm.
Yeah.
What's his name, Nate? Cool. I would take that very famous song by that guy, I can't remember, and I would see if being guilty, quote unquote, we would operationalize it by saying like we would make people lie about something or have them choose to lie about something, and then see if guilty feet have no rhythm, see if they get worse at dancing, something that they learned that day. What's his name?
George Michael.
George Michael! Oh my gosh. I would make a test about guilty whisper. That's what I would do.
Yeah.
Why? It's in the channel title. What's next?
From Ben Meinhan. Love the show, love the hair.
Hey. I agree. Thanks.
Do we control the atoms in our body, or do they control us through the random chaos of entropy?
Interesting philosophical question, isn't it? And I think what you're getting at is what philosophers call, what determinists in philosophy, people who think that we are fully determined by the laws of physics and there's no weird, metaphysical us, would say that most people are naive dualists. By which I mean most people think, just intuitively, that there is a physical us and then there is a non-physical us. And I think we separated that into body and mind in popular consciousness. We feel like there is a non-physical part to us, maybe our mind or our spirit or what have you. And then you could kind of get at that question, right? Where, am I my atoms? Or am I something separate from my atoms? Is some me controlling my body and my mind and my brain? Or is it the other way around? Is my body and the laws of physics determining who I am and what I'm doing? That's for everyone to decide on their own as a philosophical exercise. I happen to fall on the side of if you really get down to the nuts and bolts of things, I don't think there's a whole lot of wiggle room for you to be other than what you are, which is an amazing, incredibly unlikely without context, an incredibly unlikely assemblage of atoms and molecules that come together to make technology, to talk to each other, to have love and grief and art and music, just an assemblage of atoms that do all of these amazing things, and we are our atoms determined by the laws of physics and how things interact. That doesn't remove any wonderfulness out of it for me. The fact that atoms and molecules can do this kind of thing is incredible and might be the only case of that happening in the entire universe. Could be. So I think that who you are, is determined by the atoms that you be, I'd say.
Very well put together.
Well,
From Calvin Passmore.
I add atoms to my hair to make them shinier. Yeah.
From Calvin Passmore.
Hey.
I've been trying to explain time dilation to my wife for a while.
Sure.
Could you try to explain it to a book editor?
Oh. Probably someone with a lot more experience than me in saying things correctly and succinctly. But time dilation, so is the principle in relativity where if you go really fast, and I'm not talking like anime running fast, I'm talking like moving close to the speed of light fast. When you do this, because you are moving close to the universal speed limit, the universe accounts for this in a very weird way. Because you are getting to close to the speed of light, but the speed of light has to be the same in all reference frames, as Einstein noted. Something about you is slowing down or changing in a way. And if you have mass, this is going to happen. And so a couple things happen when you go really fast. One, you contract. Space-time wise, you contract lengthwise. Second thing that happens is time dilation, and you as a organism, your clock, your time in space-time, that coordinate, that value, starts to become slower relative to everyone else. So if you were in a spaceship traveling at 99.99999 the speed of light, and you traveled at that speed for a couple of weeks, when you got out of the spaceship, 10 years may have passed outside. But that is because your biological clock, your space-time value, was going slower than the rest of the universe when you got that fast. It's harder for me to get more in detail without getting more complicated with it, but when you get close to the fastest speed that there is, it seems like the universe wants to try to slow you down in a way to preserve the relativeness of things with relativity. And one of the ways that it does that is by changing the amount of time that passes for you. It also changes the apparent mass that you have and the apparent size that you are. So the things that aren't really affected, well, anyway, we're getting too complicated, but we'll have time for one more question after this. But time dilation is the universe's way of changing a value as you get super close to the speed of light. Yeah. Bet the physics girl would do a better job than that. She's also Team Trees. Let's raise some money. What's the last question?
From Gabriel Munoz.
Hello.
Of all the popular theories of how the universe could end, heat death, Big Rip, Big Crunch, etc.
Big Rip. Don't laugh.
Which is your favorite? And which do you think is the most likely?
Well, this is a theoretical physics and cosmology kind of question of two disciplines where I'm not that good on. But if my understanding is correct, I think that heat death of the universe is, I think, the most likely one. And I think I like it the most, which I'll get to in a second. So the heat death of the universe is the idea that if there is unchecked accelerating expansion of the universe, if the universe is expanding but accelerating as it does so, the edge of space moving faster than the speed of light because it's not moving into anything at all. Ooh. Then if that keeps happening, over enough time, the space will stretch out enough, the universe will become big enough that eventually atoms and molecules themselves will be separated down to that level. And when that happens, stars won't be able to form, life won't be able to form, stellar gas and dust won't congeal into planets and other stars. The universe will slowly die from that point forward. Because nothing else will have the ability to become stars, become planets, become life. And that's more or less the heat death of the universe. And that sounds terrible, but there's something interesting or lovely to it in that right now, in the period in which we live, in which we can see stars, and the universe hasn't expanded so much that we cannot see stars in the sky anymore. That will happen, according to the heat death of the universe. We are in a very fortunate period where we're not being ripped apart, and we can see stars in the sky, and we can do astronomy, and we can do science, and we can see all these things before the end is even here. We're lucky. If the heat death of the universe is true, we are in a very lucky period where we're still able to see the rest of the universe and interact with it. And we're alive for that time. That's incredible. So, and don't worry about the heat death of the universe thing personally, because none of us are going to make it that far. Especially me. And that's all the time we have for this episode of Because Science Live. Thank you so much for joining me for everything on the Because Science channel this week. Go check out the last episode that we did all about Naruto running, where we got an Olympic gold medalist sprinter to do the running with us. Incredible. You're going to want to see it. Jennifer, she's amazing. Also, hashtag Team Trees. Go to teamtrees.org, which Because Science is a part of. All your favorite YouTubers, if you like The Physics Girl, Smarter Every Day, Adam Savage, Mr. Beast, Mark Rober. All of your favorite YouTubers are doing it. We want to raise $20 million to plant 20 million trees by 2020 with the Arbor Foundation. Please go do that. Support that. It's not going to solve everything, but it's going to show that we can come together and do something positive for the planet. It's done a lot for us, like form the beings such as we be. Have a wonderful rest of your weekend. Next week, we have more of the same. New footnotes, new episode of Because Science, another one where we venture outside the void, I'll hint at, and it's very fun, especially if you like card games. And another Because Science Live. I will see you then. Have a great rest of your weekend, and be nice to each other, because before the universe stretches out so much that everything dies and nothing can therefore be ever again, this is all we got.